Hello everybody, today I'll be talking about NSAA math problems, specifically the harder ones. So let's start with question number 4. So we got two dice, X and Y, which all have 6 sides. And the faces on X are labeled here and Y are labeled here. And we want to find out that the total score must be greater than 9. And what's that probability? So it means it's greater than 9, not greater or equal to 9. So let's start by listing out the combinations. And we look at something quite interesting. So let's start with number 4. So 4 and 6 makes up 1 with this one, and 4 and 6 makes up 1 with this one. So 2, 4, and 6. How about 5? So 5, is that? And 5, 6, and 5, 6. So here are all so we got a total of 5 combinations. And you say, okay, how about I do the other way around? Let's say I start with number Y, but here, actually dice Y instead of dice X. But the result will be the same, just different order. And since here we're considering combination, order does not matter. Now let's find out the total number of combinations. So we got 6 sides here and 6 sides here. So the total number of combination will be 6 times 6, which is 36. So now the probability is pretty easy to calculate. So it's just 5 divided by 36. So what do we have? So the answer is E. Now let's move on. Question 10. T is inversely proportional to the square of W. So we can write here, T is K divided by W squared. K is some number we don't know, it's a constant. And we know that when T is 36, W is 2 times 10 to the minus 2. Equals to K divided by 2 times 10 to the minus 2 squared. K is 36 times. You might be tempting to solve the actual value of K, but I suppose you not to because you have limited time. Okay, now let's move on. So when T is 100, what's the value of W? Okay, W squared equals to 36 times 2 times 10 to the minus 2 squared over 100. And we can do some simplification. So this is why I told you not to calculate the value too soon. And we got something like this, 4 times 10 to the W squared. Take the square root of both sides. And we don't have to consider negative case because T and W are all positive numbers. So we eventually get 6 over 5 times 10 to the minus 2. That's W, which is 1.2 times 10 to the minus 2. So the answer is B for this case. Now, let's move on. Okay, so we got 3 different numbers are chosen at random from this 5 sets of numbers. What is the probability that 3 numbers form the 3 sides of a right triangle? We know that the properties of right triangles, a squared plus b squared must equal to c squared. And we can start listing out the combinations. So that's definitely 1, and we got 2, root 2, root 3, and root 5. And what else? Think carefully. 1, 3, 4. That's another one. And how about now? Let's think. 1, 4, and 5. And is that everything? Yes, that's everything. We got a total of 4 combinations. Again, here order does not matter because it's combination, not permutation. And how about the total number of combination of choosing 3 numbers from 5 numbers? So that's just equal to C 5, 3, which is equal to 5 factorial over 5 minus 3 factorial, which is 2 factorial times 3 factorial at the bottom. So it's 5 times 4 divided by 2 times 1, which is 10. So now we got everything we need. So this is just 4 divided by 10, which is 2 over 5. So the answer is E. Pretty simple, huh? This one is quite interesting. The point Negative 1, 5 is translated to 0.32 by 2 successive translation. We got the third, first, and second translation. What's P plus Q? So now let's try something. So negative 1. So first translation is 3P, the second translation is Q, and we got the final, which is 3. This is for X case and Y case. So 5 here. Let me just underline everything. 5 here plus, no, actually minus 4P minus 2Q. That number is equal to 2. You might be tempting to solve both P and Q to find P plus Q, but I suggest you not to, because look carefully. When you add up these two equations, you find something spectacular. Let's see. Got here, and we got here. Move this to the other side. Okay, so P plus Q is just equal to negative 1. Spectacular, we don't even have to find P and Q individually. This just gives it to us, which is really, really convenient. So P plus Q equals to negative 1. Now let's look at the last problem. So consider a graph of the form y equals to x squared plus 2ax plus a. What's the complete range of values of a for which the minimal point of the graph lies above the x-axis? What does that mean? Let's draw a graph to visualize this. So this means that this graph never touches the x-axis. So for the equation x plus 2 squared plus 2 squared plus a equals to 0, it has no real solution. And what's the way we can represent that? So the actually correct way is b squared minus 4ac is less than 0. What's b squared in this case? B squared is 2a, and a is 1 here, and c is a here. Sorry, the notation might be a bit confusing, but I hope you guys get it. So 2a squared minus 4 times 1 times a is less than 0. So 4a squared minus 4a is less than 0. Now it's time to factorize the equation a minus 1. And we see two different cases. Let's draw a number line to visualize it. No, actually, sorry. Zero, 1. So if a is a number greater than 1, what will happen? This equation will definitely be bigger than 1, bigger than 0, so it's positive, which is not what we want. However, between 0 and 1, so in this case, this part is negative, while this part is positive, so this will satisfy our case. If it's less than 0, if a is less than 0, then this whole thing will become positive again. So we see the solution can only lie between 0 and 1, which means that C is the correct answer. Hope you guys enjoyed this video. Have a great day.